Hello, everyone, and happy World Trenchless Day. Welcome to the Trenchless Technology webinar series. My name is Jim Rush. I'm editor of Trenchless Technology. It's my pleasure to introduce our presentation, Ultra-High Build Epoxy Liners and How They Are an Upgrade to Traditional Epoxy Coatings, sponsored by Epoxytec. Today's rehab and lining solutions offer end users and asset owners a vast menu of technologies to choose from, including polymer coatings, such as epoxy coatings. The current range of coatings has also evolved. Traditional epoxy paint coatings that were designed some decades ago for simple immersion-grade protection against corrosion have been tuned up. Now, innovative manufacturers of coatings are offering completely overhauled applied polymer coating and lining products, bringing them into a category of their own, a category of applied ultra-high build polymer lining. Today's presenters are John Thompson and Michael Caputi. John has been a coating professional for over 25 years. He's certified by both NACE and SSPC as a coatings inspector and holds a master's degree in business administration. He's currently the sales manager and technical consultant for Epoxytec and specializes in solutions for wastewater rehab. We also have Michael Caputi. Michael is the CEO of Epoxytec and has been involved in coating since 2001. Michael was the co-chair of the NACE section of South Florida and holds both a NACE certification for coating inspection and an SSPC certification for concrete coating inspection. Michael participates in Epoxytec's technical authoring and with committees involving coating design, rehab methods, and structural lining designs. He also participates in the company's R&D efforts as a bridge between chemists and the field. Following their presentation, we'll have a question and answer session, and we encourage you to participate by typing your question into the designated panel at any time during the presentation. After the Epoxytec presentation, Trenchless Technology is proud to present our 2020 Project of the Year winners in recognition of World Trenchless Day. So please stay tuned for that. So let's go ahead and get started and welcome our speakers, John Thompson and Michael Caputi.
Good afternoon, everyone. This is John Thompson. I'm the sales manager and technical consultant for Epoxytec International. I want to thank you all for being here today on World Trenchless Day and wish everyone a happy World Trenchless Day. Our webinar today is going to be, the subject is going to be about upgrading from traditional coatings to ultra-high build, high-strength epoxy linings. Our contents that will be covered in this presentation: Epoxytec will be presenting the following: about Epoxytec, examining traditional coatings, wastewater-specific conditions, upgrading to fit the need, and Epoxytec, a resource. Presented by me, John Thompson. Before we begin, please note my contact information below. Today I will be presenting concepts from a broad perspective. Should you want to discuss any of the information in more detail, or if you have a project in mind, please contact me at the below information. About Epoxytec. Epoxytec is a formulator, manufacturer, and consultant. Through R&D, we create high-performance, applied epoxy coatings and lining technologies for immersion protection in harsh environments. Epoxytec formulates its products to fit within the needs, requirements, and service conditions of water and wastewater applications. Specifically, it's Epoxytec's main industry and focus. Epoxytec's chemists obsessively focus on design criteria and solutions typical of water and wastewater infrastructure, including drinking water approvals, H2S resistance, and sealing against head pressure or I&I with high mechanical strength applied lining materials. Examining traditional coatings. Corrosion never ends. Also never ending are the amount of different types of coatings. If anyone has been involved in applying or specifying coatings that are used in immersion lining of wastewater, has likely witnessed some of these shortcomings of traditional thin film coatings. Examining traditional coatings. Before driving into some of the common limitations of thin film traditional coatings, we should better define traditional coatings. Exploring some of the history will help. Let's examine 20th century solutions that the U.S. adopted to protect against corrosion, new innovation available today, the various conditions owners are fighting against. We first begin with some basic history of wastewater immersion protection. During the turn of the last century into mid-century, sewer and treatment systems utilized reinforced concrete and steel were advancing to help replace old wooden infrastructure, non-reinforced concrete, and brick from the era before. In order to accommodate mass population growth, a reactive response to deal with rapid production demand resulted in little consideration for long-term protection. Additionally, the corrosive forces weren't fully appreciated yet with the materials selected during this boom. Metal structures were forged thick, and wall thicknesses brought assurances of long-term integrity. As reinforced concrete entered the scene, the thought was similar. The reinforcement in the concrete would protect for quite some time before all the dense wall thickness corroded. And off to laying pipe and building. Construction marched on. If coatings were utilized, they were rather unrefined early in our history. Over the centuries, initially, coatings were simply mixtures of crude pitches and solvents. They were brittle at low temperatures and soft and sticky at warmer temperatures, which limited their use. However, the early to mid-1900s did bring some advancements. Eventually, over time and upon inspection, some panic began to form as miles of compromised and corroded assets were failing faster than anticipated. Around the mid-century, investigating other industries such as automotive, oil and gas, and marine for upgraded protection solutions began. Other industries and paint manufacturers were experimenting with interesting chemistry and polymer coatings, such as epoxies and polyurethane. But those were novel at the time and quite expensive. And the general consensus for such a vast amount of square footage that wastewater required demanded the use of coal tar or some other bitumen-based coal tar enamel, CTE, for wastewater protection, while water assets still remained pretty much unprotected. CTE did provide a layer of protection from direct attack and was economical. As paint companies continued to innovate and polymer science became more mainstream, it was only a matter of time before epoxy, a terrific binder for immersion protection, and coal tar economics combined, giving rise to the ever-so-popular coal tar epoxy coatings. The introduction of bitumen-based epoxy paints entered the market to serve for decades and continued in many areas, such in competitive new construction specs. The pneumatic coal tar epoxy coatings are still widely specified for waterproofing buried assets and lining sewers, and some other solvent-based, non-tar, marine-grade protective coatings were offered alongside. So why not continue with these technologies? What's the problem? The answer is, well, in time upon inspection, it became obvious that thinner, coal tar, or marine-grade protective paints, even if made with polymers, polyurethane, epoxy, etc., could not bridge every condition, in every climate, for every level or type of force or corrosive. In addition, our culture has been increasingly limiting the number of solvents in VOCs. Eventually, in the latter part of the last century, improved 100% solids epoxy protective coatings also emerged for wastewater protection needs. Even with film improvement using 100% solids formulation with no solvent and no shrink, certain conditions still presented challenges. Although an improvement for immersion service, these coatings still delivered a non-structural film, falling short in some unique conditions that would otherwise require higher mechanical strength and bridging. The problem. For the traditional coatings mentioned, the main problem were the forces and conditions at play. Thin film coatings in wastewater environments struggle to deal with the conditions which the other industries did not have to contend? Could these films really navigate abrasion, erosion, bonding to questionable substrates or surfaces, and bridging various pressures building behind the film? Understanding corrosive forces and conditions in wastewater became a priority, as limitations became apparent with many traditional coating systems. So we come to our first poll question. According to the Society of Protective Coatings, what percentage of coating failures are attributed to wrong product selection, incorrect specification? A, 12%, B, 35%, C, 41%, or D, 70%? And if you would, please answer the survey question on your screen now. Well, I'd like to report, okay, the results are still coming in. The majority, and here's the way the percentages come out. At this point, 2.2 believe A, 2.2%, 15% believe B of 35, 33% believe 41, or C, 46% believe 70. The actual answer is C. According to the Society for Protective Coatings, what percentage of coating failures are attributed to wrong product selection or incorrect specification? That's 41%. It turns out that the coatings fail a massive 41% of the time from improper coating specification authoring, which also includes specifying the wrong types of coatings for specific conditions and environments that are intended to service. Most coatings are good, but simply placed in the wrong environment or didn't have a proper system spec to support them. 11% has to do with a change of conditions or environment not originally assessed. 46% from improper prep and or application. And only 2% from defective material. Digging deeper into the limitations of traditional coatings requires exploring the various conditions that exist throughout the U.S. regarding wastewater and why traditional coatings have difficulty in these conditions. Common conditions, corrosives, and forces which wreak havoc on traditional coatings. Number one, hydrosulfuric acid, aka H2S gas. We all know this one pretty well. The very acidic concoction of hydrosulfuric vapor, gas, and sulfuric acid is simply detrimental to the concrete and many metals. In sewer and wastewater service, depending on levels of microbiological activity, H2S can soar in concentrations that some coatings just can't handle. Secondly, moisture and adverse substrate conditions. Two-component thermosetting polymer coatings often can be adversely influenced by high levels of moisture and contaminants. In wastewater, coatings attempting to cross-link need to contend with surface saturation, wetness, condensation, and low pH. Often these conditions cause either a natural bond breaker or they may simply interfere with curing as foreign penetrants interfere with the intended molecules needed for optimal polymerization. Number three, abrasive and erosion. Not typically associated with corrosion, but abrasion and erosion, especially when found near pumps, lift stations, headworks, and digesters and grit chambers, can effectively weaken and wear the surface of the coating. For thinner films not designed for abrasion, or that just don't have enough film build to sacrifice a little bit of surface wear, the results can be rather devastating. Number four, resistance to long-term degradation. Natural degrading forces are constantly corrupting a coating or polymer. All polymer coatings eventually succumb to the slow degradation due to oxygen and acids and sometimes UV. The effect is typically accelerated when the film is less filled or thinner. And number five, forces behind the film. We finally conclude with the often overlooked condition. And when not considered, many certainly be detrimental to traditional non-structural coatings performance in water and wastewater service. The forces that build on the backside of a film are common causes of failure and often incorrectly diagnosed and misunderstood. The perception many observers have when a coating fails is that there was poor surface preparation, and that could be correct. But when you investigate further, there are at times other hidden culprits that no matter how great the prep was, these forces were not accounted for and led to the failure. Bridging these forces is seldom considered when prescribing a coating system. A condition assessment should always be performed to include investigating forces that may stress the backside of a film or a coating, especially when specifying thinner, non-structural protective traditional coatings. Forces oftentimes overlooked that will present issues on non-structural traditional coatings from the backside of the film itself are water pressure, i.e. head pressure, hydrostatic, moisture vapor transfer, MVT, inflow and infiltration, I&I, water migration and leaks, outgassing and degassing of concrete, and fatigue substrate deterioration and surface imperfections. Think of it as putting down a plastic sheet. That is ultimately what you are doing with an impermeable protective coating system. Many times, forces start building as soon as the coating is applied to the substrate, and many are undetectable, such as moisture vapor transfer, unless tested for prior. As the coating attempts to wet in the substrate, some of the forces trying to surface actually fight against the coating, creating a bond breaker before having a chance to cure. And since coatings are designed to be impermeable, like a plastic sheet, the film will try to hold forces back. The forces will build, leading to blisters, delamination, and eventually compromise as the pressure relief is needed, if needed. Low mechanical strength, non-structural grade, thin film traditional coatings are many times too weak to hold forces back. Most specifiers consider one, maybe two of these influences mentioned when looking at a coating, but all must be considered and conditions assessed. If testing reveals that forces are at play, or if these suspicions of forces, conditions, or influences, then an upgrade from traditional coatings may be in order. The good news is innovation created structural grade coatings and lining solutions to deal with these factors and the other conditions mentioned. Question number 2 of our poll. What is traditional non-structural protective coatings primarily designed for? A, hold back water migration, I&I. B, provide protection against direct attack. C, bridge cracks and bug holes and other small unbonded areas. Or D, all of the above. If you would answer that poll question now, and I'll announce the results. Okay, results for our poll question. 0% agreed that A, hold back water migration I&I. 30% provide protection against direct attack. 0% bridge cracks and bug holes and other small unbonded areas. And the vast majority, 68.12%, chose all of the above. The answer is B. Traditional coatings provide protection against direct attack. Coating manufacturers rely on various primers, resurfacers, grouts, and other ancillary system components to seal leaks, stop active I&I from not influencing the film, the bridge surface imperfections. The film itself is designed primarily to deal with the corrosion or influence on the top of the film, direct attack. The film is not fully intended to provide any real mechanical strength to deal with other influences. Upgrading to fit the need. From the history of coal tar coatings to the more recent 100% solids polymer coatings, coupled with all the conditions today's coating specifier must design around, does today's technology offer a solution? Yes, there are countless performance solutions to choose from, all with different economics and properties to consider. Some are applied, some are inserted, others are layered, but many deliver high strength and performance. There is one category in particular that still offers economics, ease of application, and high strength performance. It's practical, versatile, and can be utilized on a variety of applications to navigate, shield, and bridge forces, influences, and the conditions described. It's ultra-high build, high-strength applied polymer lining, what we're discussing today. For purposes in this presentation, we will focus on the epoxy class, ultra-high build, high-strength epoxy lining. There are other polymer technologies with similar intent. The overall category is an applied structural grade coating or lining solution with high mechanical strength and high build thickness. Since Epoxytec is presenting our very own series of products called the CPP series, stands for Compound Polymer Paste, will be used as an example. Let's learn more about these heavyweight hitters and how they compare against the thinner, traditional non-structural coatings often found on common paint specs. Question. So, what to specify when dealing with other influences and conditions which may go beyond H2S gas? The answer, upgrade to a higher build reinforced liner, one that can be troweled or sprayed from 1/16 to a 1/4 inch per pass and comes with brute reinforcement already incorporated into its matrix, delivering a structural grade applied FRP liner with concrete breaking bond strength built to bridge an onslaught of various variables and conditions. Structural grade coatings and lining solutions are applied liners to rehab and protect in the harshest and most severe wastewater and sanitary sewer environments, but more importantly, to bridge a variety of forces and conditions that would otherwise prove too much for a non-structural coating. Designed for pressure resistance in order to hold back I&I, seal against hydrostatic pressure, and create a barrier from influent while protecting against effluent contamination. High build enough and strong enough to line in areas of high flow, high abrasion, and wearing from erosive conditions of closed and agitated or high flow areas. The main difference of high-strength structural grade epoxy linings is that they are applied thick. Unlike thinner non-structural coatings or traditional coatings, rather high-build, high-strength structural grade coating linings usually starts at specified thicknesses of 1/8, which is 125 mils, up to 1/2 inch, which is 500 mils. In the case of many structural grade coatings, especially Epoxytec CPP series, the epoxy itself consists of advanced resins with a reinforcement package of proprietary fillers, such as fibers, ceramics, polymer networks, and advanced materials to form a reinforced network once cured. The technology is defined as a hybrid form of FRP, ultimately delivering high mechanical strength. However, not like traditional fabric impregnated FRP, rather the system is applied and a bonded FRP epoxy. When sprayed, the product is first liquefied from a paste grade material with micronized fibers within it. Then pump and spray applied direct to concrete DTC or direct to metal DTM. The technology is defined as a hybrid form of FRP, ultimately delivering high mechanical strength. However, not like traditional fabric impregnated FRPs, rather the system is applied. Sorry, I apologize, I hit the wrong same slide. Designed with the previous conditions and forces mentioned earlier in this presentation in mind, the film integrity at a minimum of 125 mils is designed to bridge unbonded areas should these areas occur by accident, up to a diameter estimated of 6 feet with forces building behind it. Can your everyday film do this? Thin film do this? This provides the reassurance that not only is the film high strength and self-supporting, but also made to hold back the pressures that would otherwise be devastating to a thin, non-structural, traditional coating. In fact, the flexural and tensile strengths are high enough to even plug into the ASTM F1216 structural calculation. Let's look at a few case studies and pictures of projects that have already been completed using this type of high build system. This is Miami-Dade North District UNOX tanks, rebuilding of the support structure. An example of high build, high strength epoxy for wear and abrasion, resistance on columns of a digester near agitators. As you look at the before and after pictures, you can see the water line in the first picture, the exposed rebar, as well as the profile that is on this substrate. By the third picture on this slide, you can see that it has been completely filled in, lined, resurfaced, and sealed with Epoxytec CPP to protect this asset for long term. The second picture, this is a city of Fort Lauderdale lift station lining, utilizing Epoxytec CPP trial grade, an example of high build, high strength epoxy easily overcoming the surface imperfections and filling the bug holes direct to concrete. Look at this picture, the CSP is somewhere around 5. You can certainly see that the product is more than capable of bridging that type of profile as well as resurfacing and lining the substrate. This is an example of a grit chamber in the city of Naples utilizing Epoxytec CPP. This was a midnight shutdown with only 4 hours to return to service. CPP is capable of quick return service times as well as being a structural epoxy liner as well as a resurfacer. Unique to our product is the time that we can put back to light service, which would reduce the downtime of any unit, structure, manhole, boat collection, or treatment. This is a New York culvert pipe lining utilizing Epoxytec CPP spray liner. This was high build reinforcement of corrugated steel culvert, holding back I&I between the seams. This project, CPP was able to bridge all the leaks of the seams, which were significant. That is what a structural epoxy can do. This project was just completed, the West Palm Beach digester lining, utilizing Epoxytec spray liner out of our Epoxytec CPP spray liner series. High build, high strength epoxy lining to protect against wear and abrasion, seal against I&I, and shield from H2S. Structural epoxies can be used in conjunction with CIPP and other lining solutions. This is the city of Tampa with in situ form and elbow tie-in utilizing Epoxytec CPP, applied structural grade epoxy lining to merge with CIPP at an elbow of the pipe to create a monolithic transition. This is a slide of Miami-Dade influent pipe utilizing Epoxytec CPP. You can see from the first slide the obvious grooves from the previous lining that is in place. The second slide shows the capabilities of a 100% solid structural epoxy to not only fill those voids, but also create a uniformed appearance and structural line and protect the asset. CPP Spray Liner Series, or CPP Series, is actually also available in Spray Liner 61 for potable water. This is the Peace River Authority filter tanks utilizing CPP Spray Liner 61. So we come to our third poll question of the day. What is a high-strength structural grade coating or lining system primarily designed to do? A, hold back water migration, I&I. B, provide protection against direct attack. C, bridge cracks and bug holes and other small unbonded areas. Or D, all of the above. And if you would please, will you please answer that on your poll questions now? Okay, results are in. 2% chose A, hold back water migration, I&I. 0% chose B. Almost 2% chose bridge cracks and bug holes and other small unbonded areas. And the vast majority, 96.3%, selected all of the above. And that is the correct answer. Well done to the entire group. Structural grade coatings and linings with high mechanical strength are meant to have high build, high strength films that can serve to hold back pressures, including I&I, bridge imperfections, and small unbonded areas, while also providing corrosion protection. So let's have a quick review of a summarized comparison between traditional thin coatings and high builds, 100% solid strength epoxy lining. Common condition number 1, hydrosulfuric acid, H2S gas, hydrogen sulfide. A traditional coating, epoxy and other polymer coatings are formulated to deal with H2S. However, the failure mode is not always from attack on the film itself. Rather, if a thin film, when the presence of pinholes or other long-term abuse, i.e. cracks, degradation, porosity, allows sulfuric acid to quickly accumulate behind the film with devastating results. Versus high build, high strength applied epoxy lining, often specified at 125 to 250 mils, allowing surface imperfections and pinholes to easily collapse on themselves. And the film thickness is high build enough that long-term degradation and other surface defects won't allow sulfuric acid to find a compromise to exploit. Common condition number 2, moisture and substrate conditions. Traditional coatings. Wastewater surface prep is hard to perform. Years of saturation and contamination can prove difficult to overcome. Bridging moisture, humidity, condensation, and other surface imperfection requires certain chemistry. Traditional coatings often suffer with bonding, especially when applying direct to steel or direct to concrete. Once disbonded, begin to delaminate. An ultra-high build, high-strength applied epoxy liner. Epoxytec CPP series is formulated only with wastewater environments in mind, knowing intimately the needs of bonding to both steel and concrete in high humidity and on surfaces that are moist. The curing agents and resin systems selected by our chemists undergo wet adhesion testing, and oftentimes the epoxy will even cure underwater. Should an unbonded area occur at 125 mils minimum, the film strength is designed in many cases to hold back I&I and MVT, moisture vapor transfer. Common condition number 3, abrasion and erosion. Traditional coatings. Most thin film coatings do not incorporate a network to deal with constant erosion and abrasion across its thin, low-strength film. Having a higher percent of polymers with fillers to reinforce a film to deal with high fluid flow erosion and silt abrasion would not only drive up the price, but would also be overkill for many other industries. A commodity coating may suffer quickly. High build epoxy, CPP. With 125 to 250 mils, a high-strength buildup of these films are typically fortified with a variety of hardened materials, fibers, and 100% solid resin, curing to provide a backbone that deals with the erosion and abrasion from wastewater collection, pumping, and treatment. At Miami-Dade Water and Sewer, for example, the Epoxytec CPP epoxy is specified to protect columns around an agitator of a closed digester against abrasion and erosion, and in the grit chambers and master lift stations for the same reason, as was evident in one of our case studies that we reviewed earlier. Common condition number 4, resistance to long-term degradation. Traditional coatings. Degrading forces such as oxygen, ultraviolet, and constant exposure to H2S ultimately fatigues polymer binders, drying, chalking, and degrading films to the point of failure. Thin films may be designed for immersion, but not necessarily designed for the above waterline or an open tank suffering from natural degrading forces. Additionally, thinner films often lack fillers needed to shield oxygen and UV degradation. Ultra-high build, high-strength applied epoxy lining. Due to the fact that ultra-high build epoxy lining can be specified from 125 to 250 mils, these technologies oftentimes are loaded with inorganic materials which serve to reinforce the film, also creates a shield. The mixture of inorganic fillers at ultra-high build thicknesses better protects the matrix of the polymer systems from oxygen, UV, and other degrading forces, only attacking a few microns on the surface, but when fillers shield from long-term protection. The natural service life is often many times longer due to its shielding nature against long-term degradation. Common condition number 5, forces behind the film. This is the most underestimated cause of failure. Traditional coatings. As mentioned before, traditional coatings are non-structural. A thin film is intended to protect against direct attack on the top side of the surface. Thin mill coatings simply lack the mechanical strength required to hold back or bridge other influences of forces. Water pressures, as in head pressures, hydrostatic, etc., moisture vapor transfer, MVT, inflow and infiltration, I&I, water migration, leaks, outgassing and degassing of concrete, fatigue substrates, and surface imperfection all cause concern for non-structural coatings. And these conditions are prevalent in water and wastewater rehab and lining projects. This is why specifiers should move more towards ultra-high build, high-strength applied epoxy lining in order to bridge and hold back many of these influences for immersion lining of water and wastewater infrastructure. So Epoxytec as a resource, how can we help? Epoxytec assists owners to ensure they get what they pay for, selecting the best system for the intent and need, writing application specifications according to manufacturer spec, NACE, and CSI formats, qualified pool of contractors through our certification and training programs, and other quality controls. Warranty options, variables from 1 to 10 years, depending on the application. Why team with Epoxytec? How we help? Assessment of job site project troubleshooting. We're active in the field. We're active with our engineers and with our applicators so that we can provide the best systems for the project at hand. Analysis and knowledge gathering to better understand the type of corrosion to prescribe the correct system. Assisting engineers in designing rehabilitative and protective systems. Co-development of rehabilitation and coating design to CSI formatted specifications to include quality controls, contractor qualifications, inspection and testing methods with the intent to meet the expectations of the owner in accordance with SSPC, NACE, and other industry-specific standards. Continual support to the owner, engineer, and contractor before, during, and after system installations. So as a summary of our resources, we will provide any type of technical data or information or inspection around the type of specification for the needed project at hand and what the budgetary concerns are, as well as the protection expectations of the owner. Technical data sheets that demonstrate all the product's attributes as well as mixing procedures and the performance characteristics. Third-party testing can be found on our website. Case studies of articles, pictures, videos, and etc. And I stress everyone on this call to spend some time on our website, as there are specifications, third-party testing, technical data, information that supports this presentation and our brand. How to use guidelines, sample specifications, and more. Thank you for taking the time for this presentation. This will conclude the slide portion of this presentation, and we will move to the Q&A portion of this presentation.
Okay, great. Thank you, John.
Thank you.
We'll just go ahead and jump right in with some of the questions. Just as a reminder, if you have not submitted your question yet, go ahead and do that using the Q&A panel, and we'll get to as many as we can here. So first question, does Epoxytec have a specification already written out for a high-strength, high-build system?
That's an excellent question, and yes, we do. As an industry leader, we have those sample specifications on our website. Again, I encourage everyone to visit our website. On the draw-down menu, literally the first tab will have both structural and non-structural specifications for both concrete and steel substrates. That can be not only a guide to an applicator, but as well as a guide for engineering specifications for any project. But let me stress this as well. Even though we do have the sample specifications on site, we believe in working in conjunction with the engineers to make sure that we provide the right specification for the right type of application needs.
Okay, thank you. For cost reason, if we had to specify a traditional coating, what would you advise an engineer to explain to the owner?
I would advise an engineer, that's a great question as well. I would direct the engineer to direct the owner to the limitations of thin coats versus structural FRPs. There are always budgetary concerns, and certainly we want to meet those expectations. However, money, being penny smart and dollar dumb, doesn't always work in municipalities. And with engineers, we want to provide a long-term solution rather than something that you would keep investing in every few years. So although there may be cheaper systems out there, we recommend really doing your research, understanding the technical data, and presenting to any owner the differences between a thin coat traditional coating and 100% solids coating in terms of the forces that attack the surface of the coating versus the negative pressures against the back of the coating.
Okay. Can the product be used to coat green concrete? And what is the minimum cure time on new concrete and on grout used to patch voids or reprofile manholes?
We do not recommend it being going direct on green concrete. We have systems, other ancillary products that complete the system. For example, our Ceramico epoxy mortified or fortified mortar is an excellent barrier coat to be used before the CPP is applied to green concrete. In addition, we have a product called SED, as in Sam Edward David, which is a barrier coat as well applied below the CPP to underneath CPP for green concrete. Otherwise, if you're not going to use a pre-treatment of that concrete, we recommend waiting the 28 days. Okay.
So do you grout runners and gushers before applying Epoxytec CPP?
Yes. Yes. Although we do have ancillary products that are for stopping leaks and inflow. If you have a gusher, it is recommended that you use a chemical grout in order to block that before applying the CPP.
Okay. So next question up is, what do you expect the useful life of a CPP to be, and what level of warranty do you provide against what types of failures?
We provide, our warranty system is a partnership between our certified applicators and Epoxytec. We work together to ensure the greatest longevity to protect your assets. Now that's a tricky question because epoxies are built on, certain epoxies, high quality performance epoxies are built on like a 50-year lifespan. We have seen CPP in Miami-Dade up to close to 20 years old where you can still see the trowel marks from one of our trowelable versions. Our expectation is most likely that it would be, it's hard to describe because different influences will affect the product depending on the application. But as a general broad brushstroke answer to that, we can provide up to a 10-year warranty, and if that project or that substrate is properly maintained, we are willing to discuss an inspection system and can do an extension warranty at the completion of the first 10 years.
Okay. So the next question up, it says, we are a small rural community. Our concern is with aging storm sewer system varying in diameters from 6 through 12 inches. The material is normally clay pipe and unreinforced concrete. We are finding when we have a failure, the pipe is cracking and settling. Would an epoxy coating be a viable option?
Yes, it would be. Now, obviously, in any type of application, CPP is designed to stick to literally or adhere to literally any prepared substrate, including rubber. So this type of application is perfect for CPP or a structural epoxy to be more specific or less specific to the product. But you do want to do it with that type of application with a certified applicator, and that the preparation is done correctly. But yes, as applying it as structural epoxy at 125 to 250 mils would create effectively a cylinder inside of a cylinder and would protect it from continued deterioration.
Okay. How do I know when to specify a structural coating versus a non-structural coating?
That's an excellent question as well. The real question here was the influences. I mean, and the expectation of the end user or the owner of the structure or the unit. If you're having backside influences such as hydrostatic pressure or really anything that would add pressure to the back of a coating, that you need structural enhancement of the substrate, whether that be a clarifier, UNOX tank, or something on the collection end like a lift station or a manhole. That's when you would want to use a structural epoxy, a high build. Now, personally, I would recommend using it in every application need in wastewater because we're able to provide a better warranty and greater long-term asset protection with this type of product. However, if the whole world can't paint CPP, certainly what you want to consider is it being a product designed to rehab and protect against those backside pressures that a traditional thin-coated epoxy simply will not be able to hold up to.
Okay. So when a coated pipe system has impressed current or galvanic CP, can the CP damage the coating? How can coating damage be avoided?
I'm sorry, can you read me that question again?
So when a coated pipe system has impressed current or galvanic CP, can the CP damage the coating, and how can coating damage be avoided?
That's a pretty technical question that I can't get into a short answer with. Whoever asked that question, if you wouldn't mind, I would like to get with them offline and discuss that question. That's not an easy answer, and we'll get into some specifics if possible. And by the way, thank you for that. That's a great question. I just want to make sure and answer it efficiently, and I can't really do that on the phone today. But I will get with you offline, and we'll discuss that question and its answer.
Okay. So that brings us to the close to the end of our session here today, but with the Q&A portion anyway. So I'd like to thank John for providing the presentation and entertaining the questions. So any of the questions that were not addressed here in the live session, we'll address offline. So look forward to receiving an email. We do appreciate all your participation and your attendance today, and thank you to Epoxytec for sponsoring and bringing the webinar to us today. So thanks everyone. And with that, we'd like to change gears a little bit. And in honor of World Trenchless Day, it's our pleasure as Trenchless Technology Magazine to announce our 2020 Projects of the Year award winners. So first of all, we'd just like to make a quick announcement. We do have the World Trenchless Day Sweepstakes that was sponsored by Trenchless Technology Magazine and or presented by Trenchless Technology Magazine, sponsored by Applied Felts, Max Liners, Michaels, and NESTT. And the winner of the drawing was Mary Thomas. She's an engineer with the City of Los Angeles, and she wins a full registration to the NESTT 2021 No Dig Show in Orlando next spring, and also airfare and accommodations to the host hotel. So congratulations, Mary. I look forward to seeing you in Orlando. So on to the projects of the year. We'll get started with a little bit of background. These were started in 1993. They're presented in two categories, new installation and rehabilitation. And they take into account the following criteria: technical advancements, technical complexity, milestones and records, interaction and cooperation, and industry advancement. So each of the new installation and rehabilitation category winners are selected by a panel of trenchless experts, and certainly appreciate their involvement and participation in making these awards possible as well. So we'll get started in the rehabilitation category. The first honorable mention is the SAWS Multiple Sewer Shed Package 2A. Project owner is SAWS, the San Antonio Water Systems. Engineer is CDS Muri, and the contractor is SAK. So this project included the CIPP rehab of nearly 15,000 feet of 24 to 72-inch pipe. So the next honorable mention in the rehab category is the rehabilitating 1,890 feet of 20-inch water line through a 90-degree bend with a high pressure requirement. Project owner and contractor was Water One, and Primus Line was the supplier. So this trenchless solution in Kansas City overcame a variety of obstacles and saved the owner more than $1 million. Up next is the runner-up in the rehab category, and that is the world record 42-inch cast iron gas main CIPL rehabilitation. Project owner and engineer is Public Service Electric and Gas. Contractor is Progressive Pipeline Management, and suppliers included Avanti International, Carl Weiss GmbH, Miller Pipeline, and ULC Robotics. So this record-setting project in New Jersey included 7 bends and 2 steep slopes at depths up to 30 feet below grade. And the winner in the rehab category is the Guam Northern Interceptor Sewer Rehabilitation Project. Project owner was the Guam Waterworks Authority. Engineer was Brown and Caldwell and Gresham Smith Engineers, and the contractor was Michaels Corp. So this project involved 44,000 linear feet of UV CIPP rehab completed ahead of schedule as crews managed logistical and planning challenges. So congratulations to all the winners in the rehab category. That'll bring us to the new install winners. The first honorable mention is the Port PL6 Stormwater Storage Tank Tunnel. Project owner was the City of Cambridge Department of Public Works. The engineer was Kilduff Underground Engineering, Inc., and the contractor is Sika Underground Corp. with a RASA and TBM. So this project involved the microtunnel installation of a 70-inch OD steel case pipe advanced through difficult ground conditions in Cambridge, Massachusetts. The next honorable mention, we have the SR-37 off-site drainage outfall storm sewer north segment. Project owner and engineer was the Indiana Department of Transportation. Contractors were Midwest Mole, who's the prime, and Super Excavators, the microtunneling sub, using Ackerman equipment. So for this project in Fishers, Indiana, it totaled 5,920 feet of microtunneling, including a new distance record for Ackerman with a drive of 2,304 feet. So the runner-up in the new installation category is the Sur de Texas Tuxpan pipeline. This is the project owner was the Federal Energy Commission in Mexico. The engineer is Eurohinka for the microtunneling portion. The contractor for the microtunneling portion is Terratest and Eurohinka using Heron Connect equipment. So this project in Mexico was part of an overall 800-kilometer pipeline project. And the amazing thing about this project was the world record single drive distance of 7,360 feet. And the new installation winner of the 2020 Project of the Year is the Bakken, Missouri River Crossing. The project owner here was Kinder Morgan Highland Partners Holding. Engineer was Laney Directional Drilling, and the contractor was Michaels Corporation. So this HDD crossing utilized the intersect method to cross Lake Saskawea on the Missouri River to connect two ends of a 2.5-mile alignment, a 13,247-foot total crossing using a 20-inch diameter pipe string. So congratulations to all the winners, and thanks to everyone who submitted their amazing projects for consideration. We have a huge number of projects submitted this year, and it was great to see the incredible work being done by the trenchless industry. You know, especially here on World Trenchless Day. So thanks everyone for joining us. Again, thanks to Epoxytec for sponsoring the webinar today. And we look forward to seeing everyone on a future webinar. Thank you.